Question number 5 of exercise 11.2, class 8. The diagonals of a rhombus are 7.5 cm and 12 cm. Find its area. For calculating the area of a rhombus, we should know the formula for calculating that. So the formula for calculating on the basis of diagonals, we have area of rhombus is equal to half into first diagonal into second diagonal, or half of the product of two diagonals. So here we have the solution of that. Let for a rhombus, diagonals d1 and d2 are 7.5 cm and 12 cm given in the question. Area of rhombus is half into d1 into d2 is equal to half into 7.5 into 12. 2 ones are 2, 2 6 are 12, and on multiplying 7.5 by 6 we get here 45.0 or 45 centimeter square. Then question number 6. Find the area of a rhombus whose side is 5 cm and whose altitude is 4.8 cm. Now we have given in a rhombus one side and one altitude, and we know that rhombus is a kind of parallelogram, so we will use firstly the formula for the area of rhombus: base multiplied by height, that is equal to the area of parallelogram. And after that, if one of its diagonal is 8 cm, find the length of the other diagonal. For that, we'll use the formula which we used in question number 5. Have a look on the solution. So here we have in a rhombus, base is equal to 5 cm, that was one side was given. Height is equal to 4.8 cm. Rhombus is a kind of parallelogram, so area of rhombus is equal to B into H is equal to, on putting the values, we get 24 centimeter square. And after that, we also know that one diagonal is given to us in the question. So it means we have to, if we have to calculate the second diagonal, we will use this formula again. 1 by 2 into d1 into d2 on the place of area of rhombus, and that is equal to 24, which we already calculated here. And d1 is given 8 centimeter. So in putting the values, 1 by 2 multiplied by 8 into d2 is equal to 24. 2 ones are 2, 2 fours are 8. 4 into d2 is equal to 24. And d2 के साथ यहाँ पे ये 4 जो है वो multiply हो रहा है. When we will shift this 4 towards the right side, it will divide 24, and we will get d2 is equal to 24 upon 4. On cancelling out, 4 ones are 4, 4 6 are 24. So d2 is equal to 6 centimeter, and d2 is the length of the other diagonal. So we got the solution of question number 6. Question number 7. The floor of a building consists of 3000 tiles which are rhombus shaped, and each of its diagonals are 45 cm and 30 cm in length. Means for one tile which is rhombus shaped, diagonals are given. So we will use the formula of area of rhombus, that is 1 by 2 into d1 into d2. And after that, the floor of building consists of 3000 tiles. After that, we will get that area of 3000 tiles, and on getting the area, we will find the cost of polishing the floor. We have length of diagonals d1 is equal to 45 centimeter and d2 is equal to 30 centimeter. Then area of one tile is equal to 1 by 2 into d1 into d2. 1 by 2 into d1 45, d2 30. 2 ones are 2, 15. On multiplying 45 by 15, we get 15 5s are 75, 7 carry, 15 4s are 60, and 7 675 centimeter is the area of one tile, and the floor consists 3000 tiles, so we will get area of 3000 tiles. That will be equal to 675 multiplied by 3000. 0 3 5s are 15, 3 7s are 21, 1 22, 3 6 are 18, 1920. So we get 20,25,000 centimeter square. It's a bigger term, so we will convert it into meter square. 20,25,000, that is 20,25,000 divided by 100 for 1 centimeter and one more 100 for centimeter square. We'll divide it by 10,000. We get 202.5 meter square. Now here we have per meter square cost is rupees 4. So we have to calculate the cost of 202.5 meter square, which area we have already calculated. Cost of polishing the floor per meter square is rupees 4. So cost of polishing the floor per 202.5 meter square is equal to 202.5 multiplied by 4. 4 5s are 20, 4 2s are 8 to 10, it's 1, 4 2s are rupees 810 is the required answer. Question number 8. Mohan wants to buy a trapezium shaped field. Its side along the river is parallel to and twice the side along the road. If the area of this field is 10,500 meters square and the perpendicular distance between the two parallel sides is 100 meter, find the length of the side along the river. So you can see here we are given with a picture. This is in the shape of a trapezium and this is the altitude of this. As we know, we have the formula 1 by 2 into sum of the parallel sides into h, that is the altitude. So we have that h 100 meter. Now we are given with some conditions. Area of this field is given. It means area of trapezium is already given. And its side along the river is parallel to twice the side along the road. It means if this side is x, then this side is twice of x, that is 2x. So let's start. We are given with the perpendicular distance, that is h equal to 100 meter, and area of trapezium shaped field, I have written here only trapezium, is equal to 10,500 meter square. Let side along the road is equal to x meter. So as given in the question, side along the river is twice the side along the road, that is 2x meter. We know that area of trapezium is equal to half into this x plus 2x multiplied by h. Half into x plus 2x is 3x multiplied by, in place of h we'll put 100, and on the place of area of trapezium we'll put the value which is already given, 10,500. 2 1s are 2, 2 5s are 10 and 50, and on multiplying 3x by 50 we get 3 5s are 15, 150. X is equal to 10,500. X is equal to these two terms are multiplying. On the other hand side, it will divide the left side term. 15 1s are 15, 15 7s are 105, 70. X is equal to 70. side along the road is equal to 70 meter and side along the river is equal to 2 into 70, that is 140 meter. Move towards question number 9, which is top surface of a raised platform is in the shape of a regular octagon as shown in the figure. Here we have this figure. This is a regular octagon whose one side is 5 meter already given. So it means all the sides will also be 5 meter. Then find the area of the octagonal surface. So here we can see we are given with this length and this perpendicular on this line. So have a look on the solution. Now the same figure I have drawn here. So let's divide the octagon in different shapes. So we can see here we have one trapezium and this is also a trapezium and this is a rectangle. So if we will find the area of two trapeziums and area of a rectangle, we can find by adding all the area of this regular octagon. So if this is 5 meter, this will also be equal to 5 meter. This will also be equal to 5 meter. And if this one is 5 meter, because we need in a trapezium the length of two parallel sides and one height. So we have all the things given and this will also be equal to 11 meter. So firstly, area of two trapeziums, you can either give the names for this also. Okay, so area of two trapezium is equal to 2 multiplied by, we'll use the formula of area of trapezium, that is 1 by 2 into height into sum of parallel sides. 2 and 2 will be cancelled out. 2 से multiply इसलिए किया गया है because we are finding the area of two trapeziums. So अगर one trapezium का area इतना होगा, so two trapezium का area उसमें वही चीज़ को add करके वो 2 into that thing बन जाएगा. Okay, so putting the value of h is 4 meter multiplied by sum of parallel side. One side is 11 meter and the other one side is 5 meter. It will be 4 multiplied by 11 plus 5 is 16. 16 into 4, 64 meter square. Then next we have this rectangle. So area of rectangle, we have the length and breadth. So this is 11 meter, 11 meter. This is the length and 5 meter and this is also 5 meter. This is the breadth and we know that area of rectangle is equal to L multiplied by B is equal to L, means 11 meter multiplied by 5, that is 55 meter square, and adding we get the area of regular octagon. Area of regular octagon is equal to 64 plus 55, that is equal to 119 meters square. We get the exact answer. Then we have question number 10 here. There is a pentagonal shaped park as shown in the figure. For finding its area, Jyoti and Kavita divided it in two different ways. You can see this is pentagonal shaped park. Jyoti's diagram is this and Kavita's diagram is this. Here we have to find the area of this park using both ways. Can you suggest some other way of finding its area? So let's start. So firstly we will do it by Jyoti's diagram. So as Jyoti divided this pentagon shape in two trapezium. Here we have one trapezium A, F, D, E and the other one is F, B, C, D. So, by Jyotir's diagram, area of pentagon will be equal to area of trapezium A, E, D, F plus area of trapezium this B, C, D, F. B, C, D, F. You can take any name for this. So here, area of trapezium A, D, F. Firstly, we'll write the formulas. 1 by 2 into sum of the parallel sides. As we have this and this parallel sides, that is AE plus FD into height. Height is AF. This is the height plus 1 by 2 multiply. Now parallel sides in this trapezium, this DF plus CB multiply by height. Height is BF. Now the values are also given. The height is 15 meter and the parallel sides are 15 meter and 30 meter is the second. Now we will put the values. This is AE half into AE value is 15 plus DF or FD value is 30 multiplied by AF. Actually we have this total value 15 meter. So we'll not write anything here. Plus 1 by 2 into, now DF again 30 plus this CB is equal to 15 multiplied by BF. This and this is common among this 2. 1 by 2 into 45 multiplied by AF plus 1 by 2 into 45 multiplied by BF, and 1 by 2 into 45 is common among these two terms, and bracket we can write AF plus BF, and on combining this will become this AB, and 45 upon 2 into AB value is 15. So on multiplying we get 15 5s are 75, 7 here, 15 4s are 16, 67 upon 2, 2 3s are 6, again 2 3s are 6, 15, 2 7s are 14, 1.0, 2 5s are 10, 337.5 meters square. You can calculate this by dividing these two terms. So here by Jyoti's diagram we get the area of pentagon 337.5 meters square. Now the second way, by Kavita's diagram we have this, all sides of this are equal, so this is a square and triangle, so area of pentagon is equal to area of square ABCD plus area of triangle CDE is equal to area of square ABCD is equal to side into side 15 into 15 plus half into this one, this much is 15, so its base is 15, base into height. Height will also be 30 minus this 15 will be equal to 15. So 15 here. 15 into 15 is 225 plus 225 upon 2, on dividing we get 225 plus 112.5, that is equal to 337.5 meter square. Question number 11 is, diagram of the adjacent picture frame has outer dimension 24 cm by 28 cm. This is the diagram. And inner dimension 16 cm and 20 cm. Here we have the outer dimension 28 by 24 and the inner 16 by 20. Find the area of each section of the frame if the width of each section is same. Here we have to find the area of this section of this frame. So this is the same diagram. As you can see here, this and this side is almost same and 4 and 2 are same. So I've given some names like 1, 2, 3 and 4. 1, 3 are same and 2, 4 are same. So you can write here 1 and 3 are same and 2 and 4 are same. So these are in the shape of trapezium. So here for first and third the area will be same, and for second and fourth trapezium the area will again same. So you can see here we need the height also. So what will be the height? Firstly we'll check. Here we have this complete length is 24 centimeter and this much is 16 centimeter, and given in the question is the width is same. So it means 24 minus 16, we got 8. 8 and half of like 4 and 4. So here we have the height 4 centimeter. So we'll find the area of figure 1, that is half into parallel sides are this 20 plus 28 multiplied by 4. 1 by 2 into 20 plus 28 is 48 multiplied by 4. 2 ones are 2, 2 twos are 4, and we'll get 96 centimeter square. So if figure 1's area is 96 centimeter square, so it means figure 3's area, that is area of figure 3, is also equal to 96 centimeter square, as the two are same. Then we'll move towards the second. So area of figure 2, half into sum of the parallel sides. Here in this figure we have this is equal to this, that is 16 centimeter, and this is 24 centimeter. 16 plus 24 into h is same again, 4 centimeter 1 by 2 into 40 into 4. 2 ones are 2, 2 twos are 4, and 42 is 80 centimeter square. It means area of figure 4 is also 80 centimeter.